All right, it says we're live. Hey, welcome everybody once again to Astronomy Daily Live. It's 2 hours UTC on the 19th of February 2019. So hope everybody's doing well. Yeah, grab your consumable of choice. Come on in, sit back, relax, and we will think and talk all things astronomy and space and science and nerdy things like that. So yeah, I hope everybody's doing well here. Oh, hello there. Okay, we have a the usual lap sitter here, so she's decided to come up and indulge a little bit in Astro Talk as well. So yeah, so hope everybody's doing well. I stayed home today to get some more work done, and yeah, it was a moderately productive day. I think I've got I think I'm getting a closer handle on my photometric process. Excuse me. It turns out I don't know why I didn't look at this before, but you know, I'm pretty dense. I mean, I've mentioned that several times that you know, the density of this matter inside of this head is like neutron star, right? And so it's like, you know, for most concepts to actually, you know, sink in, it just takes just an insane amount of time, right? But I was looking at things the other day, and it's like, huh, that's kind of interesting. There's a very linear relationship between my photometry and Gaia's photometry, and it's extremely linear. So it turns out that and I haven't quite worked out exactly what this means yet, but there does seem to be a linear relationship between those two things, which means that I can transform, right? It's sort of a transformation kind of a thing. It's extremely similar to what is commonly done in photometric systems, where you want to transform from like one standard to another, right? So like the Johnson system over to some other system. There are well, it can be a linear transformation. It usually isn't. There are usually some higher order terms there as well. And for instance, Gaia actually has a document that gives you the transformation coefficients to third order. So I mean, in hindsight, right? It's sort of like I'm not surprised that there is this transformation that I have to do, between my system and Gaia, and when I apply that transform, I'm getting some pretty good accuracies. I'm getting around 40 or 50 millimagnitude numbers. So that's pretty good. So yeah, it's just I definitely want to keep you all informed on all of that, because I'm going along this journey, and I'm taking you with me. So whether you like it or not. So, all right. Well, let me, I'm going to look in the chat really quick. And then, so Tom and Bobby are in the chat. Chuck, hey, nice to see you again. Johnny Unitas is in the chat. Hey, nice to see you there. Welcome. Welcome back. Welcome back. So, on the panel, back from the wrestling party is Bobby. Hey, what's going on?
Oh, was it like pretty darn good as well, and it turned out to be a good one as well. So yeah, I can't complain.
Cool, excellent, excellent. Well, I'm glad you're back. Glad you're back. And we've got Tom on the panel too. So hey, what's going on over there, Tom?
Hey everybody, not too much. Hope everybody's doing well tonight. We do have one event that happened in the past on this day, and that was the discovery of Pluto. Happened in 1930.
Yeah, wow, okay. Yeah, and actually, yeah, that's kind of interesting because Clyde Tombaugh's birthday was just a couple of weeks ago, right? So
that's right.
Yeah, that was a nice little birthday gift for himself then, too. That's kind of nice. That's kind of nice. So wow. You know, I don't remember how long it took him to actually find that. Was it a few months? Was it
Tombaugh started looking for it in 1929, and he discovered it in 1930. So it was probably a year or so. But
right.
He was actually doing some of his research on the work of Percival Lowell, who had been trying to find Pluto, or the ninth planet, for over a decade. And he didn't manage to do it, although he knew it was there because of he had done the math on the wobble of Neptune and Uranus, and knew there was something out there.
Very cool. Very cool. Yeah. Well, definitely a moment to remember. Now they've found objects beyond Pluto that are larger than Pluto. Is that? I'm trying to remember. Are some of those trans-Neptunian objects, are they larger than Pluto? I don't remember.
I thought Ceres was pretty good sized compared to Pluto. I don't remember other ones.
Ceres. I thought Ceres.
That might not be trans-Neptunian, though. I don't know.
Yeah, that's definitely not. I'm trying to think of some of the larger TNOs. There's like Sedna. There's oh man, there are thousands of them now. I'm just trying to think of the bigger ones, but yeah. Well, pretty amazing. Yeah, you know, back then was definitely not a simple task, right? You know, compared to today, where we have computers that can do a lot of that work. Still have to take the data, right? You still have to take an image, and then you got to wait a few days, take an image of the same field, and then do a comparison, and then to be absolutely sure, you got to take a third one, and sort of predict where the object should be, and if it is there, then it's like, yeah, you've got it. So but yeah, doing that visually, right? Actually putting these relatively large glass photographic plates into this device called a blink comparator, right? And basically looking through a microscope, right, and slowly scanning these plates, right? You know, back and forth and back and forth and back and forth, and not you know, tiring your eyes out and your brain out, you know, because, you know, our minds, you know, they like to drift, right? You know, you think about the shopping list, or you think about, you know, how much snow there is, and, you know, all that, and you know, you've got to pay attention, right? So it takes a, I think it takes a special kind of person to be able to do that. Now, you know, should that quality be admired? Oh, I don't know. I don't know. I mean, that's I don't know, but you know, to be able to do that and catch that visually, right? That's a major feat. That's a major feat. That's like, you know, climbing Everest, right? That's a big deal. So cool. Yeah, very, very cool. So that was wow. What is that? 70, 89 years ago?
89, yeah.
Yeah, 89 years ago. Wow. Fantastic. Fantastic. And
we'd like to welcome Ron from Earth Radio, who just got his scope today.
yeah, he actually he got it the other day, put it together, and I think is hoping for some clear skies. So yeah, he's got a Celestron. I always forget exactly what the name of this thing is. Maybe he'll tell us in the chat. But it's a Nexstar Evolution 8-inch. So yeah, I think that is going to do him well. I think eventually he wants to get into photography. So I think that's absolutely fantastic. And there are lots and lots of resources, you know, to learn how to do that exactly. You're definitely gonna, obviously, you know, Ron, you've got a learning curve, and you know, the first thing is just get to know your scope, right? Get to know your scope, get to know the sky a little bit. You know, one of the first things that you're going to have to do is do an alignment. Well, you know, you got to make sure it's clear. But doing an alignment is actually, you know, the procedure for that with, you know, sort of today's modern technology and software and all that is actually getting easier and easier and easier. You know, the ads I always see are that, you know, you don't need to know anything about astronomy, right? And you know, that's true. That's true. But, you know, I don't know. I think that there's a lot of satisfaction in knowing a little bit, right? So instead of you know, completely automatically having the telescope do the alignment, get involved a little bit, right? Because then you'll have a little bit of satisfaction there too, right? It's, you know, the shortest path is always, well, maybe not always the easiest path, but the shortest path isn't necessarily the best path, right? And I mean, it sort of depends on you. I mean, you do your thing. You'll figure out, you know, what you're going to be able to tolerate. and what you're, it's just like, okay, look, I'm just, I'm just going to have it do the whole thing, right? If that's where your tolerance level is, it's perfectly fine, right? Right? I mean, it is really, really great that that choice is now out there, and I think, beyond anything else, what I'm for is to have as many choices as possible, right? That's where it all is. Um, and Tom's exactly right. Yeah, yeah. You'll definitely be able to hook that up to Stellarium, at least eventually, right? As I said, I mean, Ron, you're jumping onto a learning curve, and so, like I told you before, just be extremely patient with yourself, right? Know that there is an end game. Know that lots and lots and lots of people have done it, right? Rest assured that it can be done, right? Even though, it may sound complicated, and to a certain extent it is, but I mean, once you figure it out, right? Like the star alignment thing, right? I mean, once you figure it out, and you do it a few times, you'll look back and be like, what? Why was I confused about this? This is the easiest thing in the world, right? But that is part of the learning curve, and I'm sure you know all about that.
And I think Uncle Bill also popped as well. Uncle Bill Bruin.
Uncle Bill popped in too? Where?
Yeah.
There he is. There he is. Yeah. Okay, cool. So yeah, he was talking about the size of Pluto. So cool. Very, very cool. So yeah, and like I said, Ron, there are lots of resources out there, but and and a lot of people who know much more about the photographic parts than me. So seek them out. There's a lot online. Get on to cloudynights.com. That's a great resource. Extremely helpful, extremely nice people out there, and they will hold your hand and guide you through the entire thing. But like I was saying, we have a lot of choice these days. We can, do a lot of these things almost completely manually, or completely automatically. So it's great. It's great. So yeah, I think if you have a little bit of patience and realize that you're jumping onto a learning curve, and give yourself time, if there are frustrations and stuff, just walk away for a while. You don't have to bang on it, right? But as I said, these days things are pretty easy, and you'll have a good time. You'll have a good time, and start with the visual observation. Take a look at some things, and move into photography, and that's a great place to be. There's so much to do in that area that I mean, you could easily fill a lifetime, just doing that, right? Extremely satisfying, and there's an art. There is definitely an art to taking that data, right? You have to, if you want to take, full color images, you have to take it in it in 3 colors, say, and you have to choose your exposure times, and you have to do this, and you have to do that, and then all the processing afterwards, right? You have to stack, and you have to, set your brightness and your contrast, and you have to weed out, pixels that are bad, and it just goes on and on and on and on. There's a lot of software out there, to do that now. And like I said, there's a lot of expertise and people that are extremely willing to help. So cool. And it's got the StarSense technology too. So yeah, like I said, you can sort of get into this then at any level, right? It can be completely automatic or almost completely manual, right? And all things in between. So yeah, you'll have a good time. But I can say that I would encourage you to lean towards sort of the manual a little bit, at least, because at least for me and what I've seen with lots of other people, there's a lot of satisfaction in being able to find, say, a target by yourself, right? Instead of just pushing a couple buttons and having it go to there, right? But do what you got to do, though too, and if you just want to be looking at things, then the go-to mount, type in the name of your object or your star, and it will go, right? And it's great. And then you can spend a lot of time just looking or photographing or whatever else, right? So yeah, that is one of the great things, is that there's a lot of choices these days. So cheers to choice. Yeah. All right. Well, cool. So I guess where I wanted to start is I actually went over to yeah, here I'll do my weather too here, just so we can see the treacherous conditions that I'm up against here. Let's see what this thing says. It's supposed to SNOW tonight, so yeah. Ooh, it's already a little cold. Yep. There's that nasty two nasty 4-letter words there. Rain and snow. Just nasty. Yeah, but that is one of the great.
It's not NSFW.
Yeah, well, one of the great things though, is that this does not last, right? It doesn't last. So it sort of is blowing through. It'll be gone in a couple days max, right? So yeah, no worries at all. It's a good excuse just to stay in and stay nice and warm. So yeah, very, very cool. All right, I popped over to the research notes of the American Astronomical Society today, and so I thought, okay, well, before I get too far, I'm just going to take everybody over there with me in instead, because I actually saw the first article and I started looking at it, and it's like, no, I really need to not look too closely at these things. I like to share this with you, as opposed to being all prepared and everything, and knowing exactly what I'm going to say. That's no fun. We're sort of sitting here on a virtual porch, just having a fun casual conversation about things. And so it's like, well, hey, let's do the real thing here. So, and I'm noticing that Mr. Tim Robinson is on the panel. Hey.
Hello, folks. I'm using my phone tonight, so the video's not going to be as good. So.
Oh, actually,
anyway.
That looks and sounds really, really good. So yeah, no problem.
Cool.
Hey, Tim.
Yeah.
Hello, Tom. How are you doing?
What's up, Tim? How are you?
Doing well, thanks.
Good. Glad to hear it. Sorry, Bobby.
I thought Bobby said something. What'd you say, Bobby?
No, nothing at all. No.
Nothing at all. All right, well, cool. So
false alarm.
False alarm. All right, cool. So so we're going over to the research notes of the American Astronomical Society, and this is sort of for me sort of the newish bleeding edge of astronomical research, right? We've got archive.org, which is still really, really good, but these little notes are just these short little 1,000-word or less articles. Usually has and I think they're limited to actually to one picture, either an image or a plot or something, right? And these.
Okay, I just want to let you know that before you continue, P and K and Mark Antonio, or I think they were doing like that supermoon or pre-supermoon tonight.
Oh, good. Yeah.
Tonight. I think supermoon.
Yeah, I understand sort of why the term supermoon is used, because it's something that a lot of people can understand, right? But in truth, what it is, a little bit closer to the truth, is what's called a perigee moon, right? And that's when the moon is actually closest to the Earth, right? So it just so happens that the perigee and the full moon, in fact, we can go over here and take a look at that really, really quick. So thank you for the reminder there, Bobby. And it's not going to be 2018, I know that. It's going to be 2019, but we can actually look. So this is actually for the year 2019. We can actually look and see that the perigee, okay, is actually taking place in about 6.5 hours, right? It's going to be at 9:07 UTC on the 19th, and it is currently, 2:29 on the 19th. So yeah, 6.5 hours or so. And the full moon. And this is
all times UTC, right?
Correct. Yeah. And the full moon takes place at 15:54, also on the 19th, right? So as it says here, the perigee occurs a mere 6 hours before full moon, So what that means is that, you know, since the moon is at its closest point to us, that also means it's at its largest, right? I mean, it looks really, really big. So you know, there's sort of a coincidence here where, you know, we have a big moon, a perigee moon, and also a full moon, right? So that's why it's, you know, commonly called a supermoon, right? Because it's really, really big and it's also full. So it's, you know, maximum size and maximum brightness, right? So yeah, definitely go outside and take a look at this thing, and you'll notice that it's well, you may notice at least that it's a little unusually bright. Yeah, yeah. So so yeah, that's what that's all about, and cool. You know, actually looking at the full moon through a telescope isn't actually the most interesting thing, because if you think about it, you know, from the point of view of the moon, the sun is basically right overhead, right? So there really aren't any shadows being cast or anything, and the moon actually looks you know, pretty flat, right? Because there aren't any shadows. You know, you really can't get a sense of depth. But you know, it's definitely a cool thing, and you know, perigee, that happens every month, right? Every single month, you have a perigee, and you have the opposite of that, the apogee, which is when, you know, the moon is furthest away from the Earth, right? And so, you know, actually nobody talks about a, I don't know what would be called, um, the apogee moon, which is sort of like a well, the opposite of a supermoon, right? So what's the opposite word of super, right? Sort of a mini moon, right? A mini moon. We're going to have a mini moon on September 13th of this year, right? When the apogee is only 15 hours away from full, right? Nobody's going to talk about that because it's not as exciting as a supermoon, right? But we're definitely going to have a mini moon for sure. But yeah, you know, these things happen at least once a year, and as you can see, you know, even last month, last full moon was pretty close to perigee as well. So yeah, it's nice how these things line up, and there's definitely a cycle to all these things too. So cool, excellent. All right, so back over to the research notes of the AAS. So this is definitely the sort of the new bleeding edge in terms of all the astronomical research going on. This is non peer reviewed work. The author, you know, submits their really short paper, and you know, the folks at the AAS, they take a look at it, spend a couple days, you know, sort of looking at it, making sure that it passes certain criteria. which they sort of lay out a little bit. And if it passes those criteria, they'll publish it pretty rapidly. I think they advertise a 3-day turnaround, but so far I don't think that I've actually seen a 3-day turnaround. And so this first one caught my eye because it talks about a transit of a planet around this star called HATS-24, right? So let's take a look at this one here. It's just, HATS is one of many survey telescopes that are looking for transiting planets, right? And that's when a planet actually passes in front of a star, and you can watch the light curve from the star actually, dim for a certain amount of time. It dims and then it brightens. It's much like an occultation, right? Except the planet usually doesn't block all the light, right? Just a very, very small amount, right? And that is sort of the case here too. So yeah, all these articles are still free, and I'm hoping that they continue to stay free, because I certainly like to look at them. And I think I'm not sure if the authors have to pay anything to actually have these published. When you go through a regular journal, the authors have to pay usually several $100s per page, right? $200 or $300 a page. I think that varies a little bit, but and so that's one of my gripes is that if the author's paying to have this published, why should I have to pay to read it, right? It's already been paid for. So yeah, anyway, this is one of my gripes. Anyway, let's take a look at this here. So they just have a new CCD camera that they're using on their system, and so they just wanted to report that they looked at this transit with it, and yeah, that's sort of what these research notes are just really quick things saying, hey, I did this, or hey, I saw this, or hey, that observation was wrong, or something like that, right? So yeah, they're using one of these new cameras, right? And using a piece of software called Astro-Image-J, which I think is freely available, if I remember right. Did all the basic stuff, the subtractions and flat fielding and extracting the actual numbers out of things, doing the differential photometry, which means they have a comparison star, and they're actually comparing that flux to the flux of the star that they're actually looking at, right, for the transit. And they talk about how they extracted the data and all that, and actually, yeah, looks like they used 6 comparison stars. That's That's kind of nice. Lucky to be able to do that. But yeah, I was kind of interested in this HATS-24, right? So, the planet is called HATS-24b, right? But the star is probably called HATS-24. So actually, I already went over to Simbad, and I did a search on that guy, and yep, that is definitely a star. It's way in the south. You can see, the declination here is way south of the celestial equator. So we up here in the north can definitely not see that. And it's a fairly faint star, right? It's got a visual magnitude of around 13 or so. So that's pretty darn faint, right? The faintest that we can see with our own eyes on a very, very, very dark sky with no lights around or anything is about 6th magnitude, right? So this
and we'd like to welcome Andy Calloway also from the UK in the chat.
Hey there, Andy. Nice to see you again. Glad you're here. So this is actually seven magnitudes fainter than what we can see with our own eyes, right? And each magnitude is a factor of 2.5 fainter than the next one. So, that's just an exponential thing. So I can go 2.5. I've grabbed my calculator, by the way, to do this. So if I go 2.5 to the 7th, that will give me a factor of about 610, right? So this star is about 610 times fainter than what we can see with our own eyes, right? And a 13th magnitude star, you can see a 13th magnitude star with an 8-inch telescope, right? It's a little tricky. You sort of have to, use your imagination a little bit. You got to stick your tongue out the right way, but you can see this. Now, with a CCD camera and a fairly short exposure, just a few seconds, you can definitely see this, right? So and I think these guys, right? These guys are using a 1.6 meter telescope. So for sure, right? A 8-inch telescope is a 0.2 meter telescope, right? So this is 32 times the diameter. Yeah, they're not going to have any problem seeing a 13th magnitude star. In fact, that's bright, right? That is actually really bright. They're using an eye filter. An eye is actually quite towards the infrared, right? So I mean, it really isn't a visible thing at all, and actually a pretty long exposure. So yeah, they are probably pushing this this thing, trying to maximize the signal to noise that they can get to as much as they can, right? So yeah, to see a 13th magnitude star with a 1.6 meter scope, no problem, piece of cake, no problem at all. And so they, so HATS was actually discovered back in 2017. At least it was reported back in 2017. This paper probably talks about the various orbital parameters of the planet itself, right? And what they are reporting here is just, sort of an update to that. So it looks like they have a orbital period of about 1.348 days. So that's really fast, right? The orbit of Mercury going around our sun is about 88 days, right? So this planet, which is pretty big, right? Let's see, it doesn't actually give the size relative to like our sun or anything. Let me zoom in a little bit here so you can see these numbers maybe a little bit better. So this is the ratio of the radius of the planet to the radius of the star, right? And it's 0.12. So that's a pretty sizable planet, I would say, right? And in fact, what this paper is talking about it being a super Jupiter, right? So pretty darn big, right? And yeah, being 13% of the size of a star, yeah, that's probably pretty big, yeah. But yeah, it's really amazing the parameters that you can extract just by looking at a light curve. And speaking of light curves, there it is. Okay, so they always like to show these things in terms of normalized flux, right? So that just means that the light from the star, when it's not being blocked, is going to be a value of 1, right? And then when the planet actually starts to transit the star, you actually see a drop in the light curve. So you can sort of see this as a percentage drop, right? So it drops by actually about 2%, right? Which is, that seems like a lot, right? But you have to remember that this is a very, very, very large planet. That's how they look at this percentage drop here, and they say, well, 2%, right? What that basically means, right, is that well, 2% of the light from the star has been blocked, right? Somehow they're able to infer that actually means that the radius is of that size. I'm not quite sure how that translates. I have to think about that a little bit. There's an area thing, right? The amount of drop here has to do with the difference in areas. So, and this is a difference in radii. So I'll bet, let's see, 13%, how can we do that? Can I do that quickly? I don't want to do that. Yeah, there's a squared factor in there. There's a factor of pi in there. I think it probably works out. Anyway, but yeah, that I would say is a pretty substantial drop, right? Because if you go back and look at the actual magnitude, right, here, right, if it is in I, so here's I, right, of 12.25. If there's a 2% drop, 12.25 times 0.02 for 2%, that's a 0.245 magnitude drop, right? That's a big drop. I mean, there are variable stars. There are actual stars that you know, that don't drop that much, right? So that's a pretty substantial dip, right? But you can also find out things, you know, how fast this drops, and you notice how it really isn't symmetrical. See how here this drop here is a lot shallower than this rise here. So that might be an indication of like um, um, the inclination of the orbit. Don't know what else it could be. The entire time it takes, right, is an indication of the orbital speed. Um, you know, and again, you know, how this drops off, I think can give you some idea as to, oh, I don't know exactly what that would mean. But, you know, I mean, it just doesn't drop square and then go there and then up, right? There's this
You say where it
gradual.
bottoms out, though, that it's pretty much a perfect arc, as in if you added more to it, it would make a complete circle. So it looks pretty arcish to me at the bottom.
Yeah, yeah. It's, you know, there's a lot of interesting structures here, right? And I think that's what this red line is. This red line is probably the result of a model. Yes, a model that you know they've got certain parameters, you know, that they can tweak around. You know, think of it as a bunch of different knobs, you know, that they can turn, right? And if you turn the knobs just right, then you get this really nice fit. And they actually show the residuals here too, right? So the residuals are just all these little blue dots minus the red line, right? And so this is, you know, all less than what, 0.5% residual. So that ain't bad. That ain't bad, right? And so let's see. This thing, it looks like it takes about 1/10 of a day, right? About 1/10 of a day to you know, from you know, the start to the finish, right? Here's 0.05 here and 0.05 there. So this whole thing takes about what, 2.4 hours or so. And I guess since they are reporting a period here too, I guess they've probably observed this several times, right? You know, because you have to see it at least twice. But that's pretty cool. It's pretty nice. So yeah, they've got a precision here. They say of 0.15%, which is not bad, not bad at all. The precision is how much this stuff is wiggling around, right? The average of this is going to be 0, but the standard deviation of this is probably where they're getting this 0.15%. So cool, very cool. So yeah, and that's it, right? You know, they just sort of you know, fill in a little bit more information, and that's it, right? So let's see. What's that, Tim?
I've pressed something on the keyboard. I've lost the chat window on the YouTube thing.
Ah, see, you're pressing keys again. See?
Yeah.
So yeah, you know.
Tim.
Sorry?
You have a nice dog here too at your place.
It's hard to
You have
tell
a
what you're
nice
saying
dog.
because you're on my phone and.
I think Bobby is commenting about your doggy there.
Oh, the dog behind me. Yeah, it's my son's dog. I'm at my son's house at the moment on the East Coast. Looking after his place.
Cool.
He's gone to
Okay.
Scotland for a week.
Very
He's
cool.
Yeah. My
He is a-
uncle's dog just popped 2 puppies today.
Cool. Cool.
Yep.
Big dogs, small dogs.
More mouths to feed.
Definitely, yeah. Yeah, this one's a dog de Bordeaux. Quite a big, some kind of a French Mastiff, I understand.
Cool. Very cool.
She's soft as putty. Soft as putty.
There she is. Yeah, she's a monster.
I wouldn't want to meet her in a challenge, though.
Heck no. Heck no. Yeah, no, I once knew a bull mastiff, and he was a big boy. I mean, his head was like, you know, the size of a beach ball, right? It's just this big, massive thing, but just the sweetest dog in the world, right? Didn't, you know, was completely not aware of his size at all. It's like, you know, completely had no idea how big he actually was, but he was a monster. He was a horse. All right, well, cool. So I was just looking here, and this is a pretty good turnaround, right? It was just a week, right? Received on the 8th, accepted on the 13th, and actually published on the 15th. So that only took a week, right? So that is really nice. It's really nice. Very cool. So yeah, that's, you know, it's kind of nice to keep track of these things. This one I thought was kind of interesting too, right? About the photon rest mass. I don't know about that. Sounds interesting. Trying to measure distances. You know, distance is like the most important thing in terms of astronomy, right? If you can know how far away something is, then you can get a really good handle on pretty much everything else, right? But measuring distance is the hardest thing there is. so yeah, you know, that's where most of the uncertainty takes place. Is it's like, well, you know, we don't know how far away it is, and you know, distances can be deceiving because there is usually stuff in between that can make it look either brighter or fainter, you know, than what it actually is. So you know, I mean, it just gets complicated, right? It gets incredibly complicated. So, all right, I think that's about it. This is the latest one. Let's just sort of see when this was put out. We're not gonna cover it or anything here. So okay, so that was actually put out on the 13th. So okay. So don't see anything new yet, at least. This is the current one, number 2, February 19th, or February of 2019. So yeah, you know, they just fill these in until the end of the month, and then they go on to volume 3, right? So very, very cool. Very nice. And yeah, I think this started back in October of 2017, if I remember right. Let's go back. So there's actually quite a few of these now. And this is being really slow. It's being really slow. Dun, dun, dun. Yeah, it's just taking its sweet little time here.
Well, while we're waiting, I found a website that says the moon is called a micro moon.
A micro moon. Okay.
Yeah.
All right. All right. Well, all right. I suppose I can accept that. I'd still call it an apogee moon, but yeah.
Well, they actually said the name is apogee syzygy moon or micro moon.
Apogee syzygy moon.
Yeah.
Syzygy. What is that all about?
Syzygy is when three objects line up.
Yeah. Okay. All right. Yeah. Yeah.
So they call it both a perigee syzygy and an apogee syzygy.
Oh, sweet. Okay. Okay. Well, you know that's actually a more precise description, right? Because perigee that happens every month, right? But those three bodies, right? The sun and the earth and the moon don't have to line up. So
Right.
cool. All right. Nice. Sweet. 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 Okay. Well, let's
It's
see.
a good Scrabble word too.
Yeah. 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 It definitely is. Is there only one? I guess there is only one Z, right? So that makes it really useful in Scrabble.
One Z and three Ys.
And three Ys. Are there that many Ys on a Scrabble game?
I don't know. That's a good question.
Ooh, good question. I don't know.
That word in Scrabble.
What's that, Bobby?
How many points you can get by spelling that word in Scrabble?
Ah, yes. Now that's a good question too, right? What are the maximum number of points that you can get for the word syzygy in Scrabble? Yeah.
It's more than 5.
Probably more than 5, yes. So anyway, here's the first one. Yeah. So back in October of 2017 is when these first came out, and James Davenport has the first one ever. Very, very cool. Because I
hate
can't
to tell you this, but Scrabble can be a pita bread if you don't know if you don't know the dictionary.
Well, you can always challenge, right? You can challenge words, so no problem there. All right, well,
Dyslexic to play that game.
Well, I think before we finish off, let's take a look at the final ISS-TV image that I was able to capture for Tim.
Oh, did you post a new one?
Yeah, I just did before you posted it out your live show.
Oh, groovy. Yeah, let's get over there and take a look. That must be it right there. Okay, so I'm gonna share my screen once again. I'm gonna hide that. Gonna go to infinity. There it is.
I'll have it full screen in a moment when it's on my computer. Nice.
Yeah.
Yeah.
I can actually pop this up and zoom in a little bit more. There we go. So, well, you lost a little bit on the front end and a little bit down here, but now, Bobby, I don't see that weird edge over here. This kind of looks funky over here, but Yeah, yeah, that seems to have gone away.
Yeah, that's the Curiosity one.
How do you get
Nice.
these again, Bob? Is it something to do with the radio signal?
Yeah. Okay. So for those of you that does not know about the ISS, or like they have in the Russian module, they have a amateur radio service that they have in the Russian module in the space station. And they'll do, like, every once in a while they'll do like a voice communications, SSTV communications. They even send out packets, and they can do anything they want in the Russian module of the space station. So this is actually, like, it was getting close around time where they actually going to shut it down. So this is probably like the last time I was able to catch something before they shut it down. So I was thinking about use this opportunity to capture it and get done.
Cool. And so, yeah,
really cool.
and so as the space station passes over Bobby, he can pick up the radio signal that they're sending out and run it through a decoder, and get these pictures, these full color pictures, and I mean, it's once in a while you'll get a perfect thing, but because of whatever, atmospheric conditions, or whatever, sometimes you get these dropouts, right? But yeah, I mean, I think it's pretty cool that they're doing this, and yeah, I think it's great.
Now, if you can scroll up and maybe show Tim like a cleaner image, that'll be great.
Oh, sure, I can do that.
Okay, there's
Let's
a
see.
cleaner image.
What's that?
Well, there's
Yeah.
that
Lost
one.
you, Tom.
Oh, is there?
Yeah, I pushed the wrong button.
There we go.
We've all done that. I do that regular with the wife.
Yeah.
There we go. So there's a nice.
Yeah, I think that's the same thing, but it's cleaner.
Oh, that one there.
Yeah.
Curiosity on that. Yeah, that's very cool. That is awesome.
There's just a little tiny bit right up here that's kind of hard to see.
Yeah,
right?
we saw that was the weekend before last weekend as well, that I was able to capture that. And so yeah, so it was from like the weekend before last weekend I captured that.
What was on your most recent image? Why do you think you had
Go
those?
back.
Yeah,
It was. Now, what are you talking about, Cosmic?
your most recent one, that we just looked at before this one. Why? Yeah, why do you think that there were the dropouts? Was the elevation not very high? Why do you think this was so good as opposed to the other one being okay, but not as good as this? This was a pretty high pass, right? I think you said
this one was about a 70, like a 75, 78
so
or
pretty
something.
high.
And the one that was the last one was like maybe a 69. So, but it shouldn't not make a difference, but yeah.
Yeah. So, I mean, that is nature.
I mean, but
right?
if you go up to where about the Apollo one, just keep going up. Okay, let's see.
That one?
And there, Apollo 8. Yeah. So, so yeah, this one maybe like maybe like a I think like 63. I forgot what it was. I never did logged it and stuff like that.
Right.
So but it there could be like some kind of obstruction, like some atmospheric obstruction or something like that. And in the last one, in the last image, I was able to capture. So we got some high clouds, big clouds. So I think it's because of the we got some big clouds in the area and stuff. It might be something like that. I think my just could tell you more about it as well.
Yeah. Well, cool. Cool. Yeah.
It was your robot girlfriend's Wi-Fi signal. It was a bit too strong, Bobby.
I think that's got to be it.
Definitely.
Yeah.
All right. Well, cool. Well, I think.
Yeah. So I can't be a little bit skeptic when it comes to like if it's either interference or like the conditions that I had at the time.
Yeah. Yeah. It's actually, you know, it's kind of kind of neat to monitor those kinds of things too, and you know, maybe pay attention a little bit to you know, it's like, okay, you know, and like you said, you know, keep some kind of log saying what the conditions are, you know, if it's clear, or you know, if there's some kind of solar activity, you know, time of day, right? Time of day might have a lot to do with it. Yeah.
The difference.
Yeah. Yeah. You know, lots of different things. So
there's Patrick Manning just joining at the tail end. I think we're about to get out of here.
Right at the tail end, Patrick jumps into the chat. Very cool. Hey there, Patrick. Nice to see you there for, if nothing else, a short amount of time. So yeah. Speaking of which, I think it is about time to get out of here for now. So well, thanks everybody for coming in again. It's always great to see everybody, and you know, to have everybody on the chat and stuff. Very cool. So all right, well, cool. I think I'm gonna get out of here for now. So
before we go, can I just quickly apologize to Bobby? That last bit that I said, it was meant to be just a joke. I didn't realize that it could have been taken the wrong way.
No worries. No worries. We're all friends here. So yeah.
It's because my robot girlfriend, I forgot to WD-40 her legs and she's seized up.
Oh man. You got to pay attention to the service manual. You got to read those things, Tim.
Too right.
Come on, you got to get with
it. Apologies, Bobby, if it sounded like I was being a bit funny with you.
Well, we know how you are. All right, you guys. Well, I'm going to get out of here. So you have a great evening, a great day. Make sure to subscribe if you haven't already. Smash the thumbs up if you like. Make some comments. Spread the word. I'm going to do this again tomorrow in a little less than 23 hours. Just one little tiny spin of this little planet. And I will be back. Feel free to join in again. Always like to have everybody here. And we'll do more astronomy, space, science, all kinds of nerdy things. Who knows? All right. So peace, cheers, and all that. I will see you all later. Bye.
Thank you very much, and all the best to you guys.